Okay, so now that we've done that review of problem solving, we want to move on today now to the next topic kind of in our list of topics, which is decimals. The key to working with decimals, just like it was the key to working with our whole numbers, is the concept of place value. Just a review for our whole numbers. The ones, the tens, the hundreds, the 1,000s, 10,000s, 100,000s, millions, and so on. Going this way, we've got the tenths. You see as we move here, by the way, every time we move one spot to the right, the place value is divided by 10. 1,000 divided by 10 is 100. Divide by 10 again, you're at 10, and so on. It keeps going. This is the tenths. 1 divided by 10 is 1/10. Divide by 10 again, you get the 100ths. Divide by 10 again, it's the thousandths. And I think you can see the pattern developing here, the 10,000ths, and so on. Well, looking at these place values here, you might be thinking they look suspiciously like fractions, because they are. Decimals are nothing more than a short way of writing fractions. They're common fractions with denominators that are just powers of 10. So if I have 0.34, what that really is a shortcut, or short way of writing 34 hundredths. It's a fraction. In fact, if we want to convert a decimal into a fraction, it is just that simple. We just converted 0.34 into a fraction. Now, we wouldn't leave it as 34 over 100 because both of those can be divided by 2. We can reduce that to 17 over 50. So if we have 0.825, if I want to convert that into a fraction, it's going to become 825 over, the denominator is the place value where that last digit was. This was over the 100th, so that's over 100. This is tenths, hundredths, thousandths, so this is 800, I don't know where the 4 came from, I'm sorry. 825 over 1,000, because it's the thousandths place. A little double check, by the way, 3 decimal places, there better be 3 zeros in that denominator. Now, of course, we're not going to leave it like that. Both of those numbers can be divided by 5. Okay, we'll divide by 5. That makes us 200 down here. 825 divided by 5 is 165. They can both still be divided by 5, which is going to give us what?
21.
Well, 33 over 40. That's it, 33/40. What if this were written like this? How do I turn that into a fraction?
Well, that's 28 and 32 hundredths.
Perfect. This is a mixed number. The part in front of the decimal point is just the whole number. So that 28 is 28, period. All that needs to be converted is the part that's after the decimal. 0.32 is 32 hundredths. Now, of course, we're not going to leave it like that. We can reduce it. Both of those can be divided by 4 to give us 8/25. Now, we have to remember that 8/25 goes with our 28 that we had. So that's 28 and 8/25. Make sense? Good. Going the other direction from a fraction back into a decimal, let's have 3/4, and I want to convert it into a decimal. Well, remember, we've talked a couple of times about how a fraction can be thought of as a division problem. 3/4 can be thought of as 3 divided by 4. If you were to punch that in your calculators, it gives you 0.75. Most of you knew that 3/4 was 0.75 anyway. If you didn't know that, you could punch in your calculator, of course. We'll go over how you divide that out by hand before we're done today. With that, actually, let's hit on our operation with fractions. Or with decimals, I should say. So anyway, adding. This is going to go relatively quick because our operations with decimals are pretty simple. And your calculators do them really quickly, really well, and fairly easily. But when we add, we have 43.28 plus 9.746. When I go to add it, now we've always done addition vertically, putting one over the other. What do I have to remember to do as I'm setting these up? Line up the decimal point. Very good. And remember, the reasoning for that was I can only combine digits that have the same place value. I can only combine things with addition and subtraction that have the same name. And for numbers, that comes right down to the place value. So I can only combine ones with ones, and tenths with tenths, and hundredths with hundredths. So now I'm going to go ahead, I'm going to fill in a 0 here. Oops, that's not what I wanted, but it's okay. And 0 plus 6 is 6. 8 plus 4 is 12, so 2 carry the 1. 1 and 2? 3 plus 7 is 10, so 0 carry the 1. Now before I do the 1, 3, and 9, I have to bring down my decimal point. I can never cross the decimal point without doing something with it. 1 and 3 is 4, plus 9 is 13. 1 and 4 makes 5. So 53.6 or 0.026. Subtraction is the same way. You have to line up the decimal point. So I'm not going to bother you with a lot of examples of subtraction. I'm just going to jump to something like this. (9.3 minus 2.7468). So when I go to set this up, I still make sure I line up the decimal point. Now I have to fill in the missing zeros here. 1, 2, 3 of them in this case. I go to subtract. 0 minus 8, however, can't be done, so I need to borrow. But I go here, and there's nothing to borrow from. So what do? Keep going. 3 is the nearest number that I can borrow from. So I borrow from that, it becomes a 2. This is a 10. But I didn't need it here, I needed it down here. So I keep going. I borrow. This is a 9. This is now a 10. Borrow again. This is a 9. This is now a 10. Now I can subtract. 10 minus 8 is 2. 9 minus 6, 3. 9 minus 4 is 5. 2 minus 7, can't be done. We're going to borrow from the 9. Does the decimal point affect this at all? Say no. No. Good. So that borrow from the 9, that's an 8. This is now a 12. 12 minus 7, 5. Can I do 8 minus 2? Mm-hmm. Say no. What do I have to do first? Bring down the decimal point. 8 minus 2 is 6. So there it is, 6.5532. Any questions? Cool. So if I go to multiply, 5.37 times 4.6. Do I have to line up the decimal points when I set this up? No, I don't. When I multiply or divide, I do not need the same name. Addition and subtraction, remember, we had to line up the decimal points because we must have the same name. Lining up the decimal points made sure that we were lining up the columns with the right place value. So we're combining things with the same name, the same place value. When we multiply here, we're going to ignore the decimals. And we're just going to do 6 times 7 is 42, so that's 2, carry the 4. 6 times 3, 18, plus 4 is 22, so 2, carry the 2. What's that? That's a 4, yes. 6 times 5. 30 plus 2 is 32. So 2, and we carry over the 3. We come down here, what do we have to do? Move one over, put in a 0. I'm going to do this too. I'm going to put a line across there so I know what I've carried. 4 times 7, 28. So 8, carry the 2. The 2 goes above the line, so I know it's a new carry. 4 times 3, 12 plus 2 is 14. So 4, carry the 1. 5 times 4, 20 plus the 1 is 21. So 1, carry the 2. And we're going to add down the columns. 2 plus 0 is 2. 2 plus 8 is 10. So 0, carry the 1. 1 and 2 is 3 plus 4 is 7. 3 and 1 is 4. And the 2. Where's our decimal point go? It's right here. Why?
Because you add up the number of decimals in the problem.
Okay, you count in the problem. 1, 2, 3 total decimal places in the problem. So there must be, starting from the end of the number back, 1, 2, 3 total decimal places in our answer. Another way you could go about this, by the way. Really, all that is, remember, is just combining the names. This was hundredths. This was tenths. Hundredths times tenths has to give us thousandths. But another way you could have done that, if you look at it, this is about 5 times about 5. 5 times 5 is 25. Well, 24 makes sense. 2.4 would not make sense. 247 would not make sense, would it? Any questions? Okay. Division. Division is the one operation, as always, that would go left to right. If I had 27.832 divided by 4.6. How do we divide by a decimal?
Do you move it over or something like that?
Well, it's kind of a trick question, yes. If we went to that, remember the first couple of days I showed you that long division process with all those extra steps in it? The real long division process, the repeated subtraction. If we were to do it that way, we could go ahead and divide with the decimals. It makes absolutely no difference. But they stopped doing it that way. And when they stopped doing it that way, it made it very difficult to divide by decimals. So like you said, Tammy, we don't do it anymore. We move the decimal place over. What you were always taught is to come here and say, okay, there's one decimal place there. I'm going to move the decimal point over one spot there, so I'm going to move it over one spot here. So this becomes 46 going into 278.32. Question is, why can we do that? Why are we allowed to do that? Why doesn't that affect the answer? Oh. Just because your 4th grade teacher said so, right? Well, remember, a fraction can be thought of as a division problem. A division problem can be thought of as a fraction. This can be thought of as 27.832 over 4.6. And in a fraction, I can multiply and divide the top and bottom by the same number, can't I? So getting rid of that decimal point, what I'm really doing is just multiplying by 10 to make that 46. So I have to multiply the top by 10 to make it 278.32. If there were 2 decimal places here, I'd be multiplying by 100. The 3 decimal places, multiply by 1,000 or whatever. So that's why, as long as you move both decimal points the same distance, you don't change the answer, because all you're really doing is working with a fraction form. So anyway, back to here. Now we're going to divide. Does 46 go into 2? No. How about 27? No. How about 278? Kind of does. 6 times. So I do 46 times 6. That's 6, carry the 3, 24, 27, 276. Everybody follow me so far? 8 minus 6 is 2. Ooh, there's nothing else left. Should we bring down the 3? We cross the decimal point. We can never cross the decimal point without doing something. In this case, the decimal point has to go up. Now we can bring down the 3. 46 into 23? 25, right? No. We can't go in there, can we? This is the point that a lot of people will forget. 46 doesn't go into 23, so it goes in there 0 times. We have to fill the place value above this number before we can bring down the 2. Now we can bring down the 2, though. It's 232. 46 will go in there 5 times, which is actually 230. If you multiply it out, there's 2 left over. Does this mean we're all done? No, we could keep going. How could we keep going? Add a 0 and bring down the 0. Now, what if I said I wanted this to the nearest 1,000? Well, I got to finish dividing here, right? Does 46 go into 20? No, so put a 0 there. So that's the thousands place. Do I stop there? Can I go, say the heck with it, I'm done?
No.
No, what do I have to do? I add 1 more 0 and bring it down. 46 goes into 200? 4 times. It would actually be what? 184. Should be 16 left over. Why did we need to know that extra digit? Because this now tells us, if we round it off to the nearest thousandth, that is 6.50 instead of rounding it up to 6.051. So we had to have that extra digit to tell us how to round the thousandths place.
How far would you have to go before it actually breaks even?
This one here would not even out. This one would keep going on forever. Well, the remainder's gone. We just wanted it to the nearest thousandth, so we don't care about the remainder. We just rounded it off.
But otherwise, you'd do 46 and then that one. Or no?
You'd add another 0 and bring it down and keep going. Once you've got a decimal point here, you can't have remainders anymore.
Oh.
Remainders only work with whole numbers. Well, I said we'd get back to it. Let's do it. If I want to change a fraction into a decimal, it's a division problem. This is 4 divided by 7. So the question we asked is 7 go into 4? That would be no, it doesn't, right? So we put our decimal point in and we bring it up. I'm going to put a 0 in front of it. And I have to do all that before technically I'm allowed to put a 0 in here. Now we're going to look at 7 going into 40. Yes, I realize there's a decimal point there, but once we bring the decimal point up, we can forget about it down here. 7 goes into 40 5 times. That's 35. There's 5 left over. Now, what if I want, now up above I said I want it to the nearest thousandth. I can say a place value, nearest hundredth, nearest thousandth, nearest 10,000th, or whatever. Well, let's say I tell you that I want this to 5 decimal places. That's another way I can specify the rounding. So, what do I do? Add a 0, bring it down. 7 goes into 50. Say 7 times, that's 49. Leaves me with 1. Now what? Add a 0, bring it down. 7 goes into 10? Once. Subtract, that's 3. Add a 0, bring it down. 7 goes into 30? 4 times. That's 28. 32. Add a 0, bring it down. 20. 7 goes into 20. Twice. 14. Are we all done? That's 5 decimal places.
You wanted to round it, didn't you?
We want it to 5 decimal places, which means we have to go to 6. Always 1 past. Put in another 0, bring it down. That's 60. 7 goes into 60 8 times. Now here it was important that we did that extra place because we're rounding it off to 5 decimal places, which is right there. But this is not going to be 0.57142. It's going to be 0.57143. The 8 tells us to round the 2 up to a 3. Questions? Comments? Complaints?
So then it's, it would, 4/7 would be 57%. We're not, that's something totally.
If you're changing it into a percent, yeah, it would be 57.14% or 57%, however you're rounding it off.
You know, like, you just imagine the teacher saying, go to the nearest billion.
Right.
Depends on how much you guys upset me between now and the time we take our test. I got a phone call on break today. I got a sick kid I've got to go pick up. So there's a new quiz that is due tomorrow, Thursday, at 11:59 p.m. New homework is due Monday. We will have time in class tomorrow to go over any of these questions. This is the type of stuff that I think you guys should be able to take off with and do pretty well with anyway. Get a good chunk out of your homework if you can before tomorrow, and we'll spend our class time answering questions on it.